Okay, let's look at the second example here for our Bcd function, our binomial cumulative distribution. So we have the election where 35% of 21 million voters favoured the red party. Okay, so we've already looked at the first circumstance using BPD, so let's look at the second circumstance. Okay, and it says, what is the probability that the majority of those selected out of 7 people favoured the red party? Okay. So if we're talking about the majority of 7, this could be 4 favoured the red party. Okay, so I'm going to call it 4 favoured. You could have 5 people favoured. How do you spell favoured? 6 favoured, or 7 favoured. Okay, all of these circumstances occur. All of these circumstances cater for the probability of the majority voting for the red party. Okay, 4 is the majority of 7, 5 is the majority of 7, 6 is, and so is 7. Okay, so once again, you could calculate all these combinations individually. Okay, and I'll show you very briefly how we would do that again, just so you know what we're doing. All right, so you understand it. So the combination, okay, out of 7 trials, 4 successes, okay, the probability of a success is 0.35, so the power of the number of successes, okay, and times as well by the number, the power, the probability of failure, so the number of failures, which would be 3, okay. So you would be calculating this for all of those, okay, and then adding all those together. That would be the probability, okay. But because we have this BCD function, we can just get the calculator to basically compute all of those for us without having to put this tedious stuff into our calculator. Okay. So we're going to look at both circumstances of looking at this then, okay. First, the more practical circumstance when we're thinking of just using the BCD function. Alright, so in statistic, distribution, binomial, BCD, okay, data's variable, number of trials is 7, okay, because we're talking about 7 voters. Alright, now the BCD asks us for the probability of X being less than or equal to some number. Okay, let's just put K in there for now. Some number K. So what we want to know is, what's this number K that we're going to put in? Okay, so we have 4 possible circumstances here. Alright, if there are 4 successes, that means there's going to be 3 failures. Okay, so we have the probability of there being 3 failures. If there's 5 successes, we have 2 failures. Okay, if there's 6 successes, 1 failure, and if there's 7 successes, 0 failures. Okay, so because this is a calculation of the probability being less than, alright, what we want to calculate then is these failures. Okay, we can say that this K value is going to be this number 3 here. We're saying, what's the probability that there's less than or equal to 3 failures? Okay, now in this circumstance, a failure is someone who didn't vote for the red party. Okay, so we've said a success is someone who voted for the red party. The probability of a success is 35% or 0.35, which means the probability of a failure is 65% or 0.65. Okay, so we're saying, what's the probability that there is less than or equal to 3 failures? And that caters for the circumstance where there are 4, 5, 6 or 7 people voting for the red party. So the case when there's 3 or less failures, alright, our number of failures is 3, our number of trials is 7, and our probability is 0.65. Okay, so we can calculate that one, and the probability is about 0.2.